Hello guys, and welcome back to this lecture. So in this tutorial we'll be discussing the basics of data science, what are the common use cases and algorithms used in data science process. If you're working in some other domain like as an architect or as a civil engineer, how you can make a transition into the data science career, and what are the skill sets and knowledge required to successfully transition into data science curriculum. So, getting started, what is exactly data science? So, data science is a subfield of artificial intelligence, machine learning and deep learning at its level. So, the basics of deep learning, machine learning and artificial intelligence involves data science, that is doing science with data. So, it's an interdisciplinary field that requires some mathematical and statistical knowledge, having some basics about how the algorithms and the numerical techniques are used to derive insights out of the data. And obviously there is a role of domain knowledge, which plays a vital role in the analysis of any project. So supposedly if we are understanding things about, say, cap price predictions, so we firstly need to have knowledge about that domain. What are the prices, what's the demand. So taking another example, if we are working in a healthcare domain, working as a doctor requires some domain knowledge about the doctor, how the respiratory system and other vital organs in the body are working. So only then we can do science and derive insights at a deeper level. We first need to have some domain knowledge. So business acumen or experience is required, which will add substantial value to your business. Above that, there are some hacking skills, data engineering, data wrangling and coding skills which are required, although not so much necessary, but these are vital skills that we need to successfully transition into the data science career. So talking about basics of some algorithms that we'll hear in machine learning, some basics are Bayes' theorem, which depends upon the probability of B which is gonna happen depending if A has happened. So if something has happened, we're trying to find out the probability of if that will happen. Given B has happened, how often will A happen? So given there is a recession happened, how many times will the market rise up during a recession? Taking an example. The second algorithm being the regression algorithm, which is finding a continuous point over time perplexity, which involves legendary Gaussian theorem and or Galton, which were introduced in the earlier 1800s. Then we come to neural networks, which were designed by McClock and Pitts in the early 1940s. Think about all the data that we compute in today's world. So browsing social media, Netflix, Google, Amazon, Cloud, Spotify, Instagram, it's all data at the molecular structure. Even in the satellite imaging that we are processing using the satellites, it's also data, and vast amounts of data. So for analyzing all of these data that's getting produced every minute and every second, we need tools to analyze these data, and for these we require some scientific knowledge as well, which gave rise to data science. Then there are different techniques in machine learning. Some basics terms we'll hear are regression, as we discussed earlier, that we are looking for a statistical relationship across variables, like how with the height, how proportionally does the weight rise. If a person is 5 feet and 6 inches and his weight is 60 kgs, what will happen if the height rises up by 2 inches? Say 5 feet 8 inches, weight might be 62 kilograms. So we are trying to find out a statistical relationship across variables that give us an estimate of a particular outcome. So supposedly if a company is earning $10 billion in 2016, So it might be able to earn, say, $20 million by 2020. So we are trying to find out the statistical relationship that is present across variables. The second one being the classification problem, wherein we are trying to find out, so similar to regression, but looking for separations in our data, which are given some predefined classes. So say we are trying to understand image of a cat or a dog. So here you are not trying to predict a a continuous point over time complexity. Rather, you are trying to differentiate between dog and cat. How does a cat look like and how does the dog look like? You're trying to find some separation, line of separation between both of them. That's classification problem. So you're trying to identify is it 0 or is it 1, applying some binary logic. The third one being the clustering problem. So clustering problems, so giving an example of an algorithm that's k nearest neighbors or knns. These type of algorithms or typical machine learning problems do not have predefined classes. Rather, so taking in the previous example, so here you do not know what does a cat look like, or how does a dog look like. You're trying to cluster different variables together and trying to find out a separation here. So you're clustering all of the data, like categorizing. So these do not have predefined classes, but they are trying to find out groups or sets based upon the data at hand. That's unsupervised learning. So classification can also be used for, in other words, it's supervised learning. We are giving the target variable and making the algorithm understand how does a dog look like or how does a cat look like. In clustering problem or in unsupervised learning, the computer doesn't know how does a dog look like or how does a cat look like. It has provided a dog a 0 label and cat 1 label. So it's just saying it's 0 or is it 1. It's like pattern matching. And the last one being anomaly detection. We are trying to detect outliers. So outliers are basically something that is like odd man out, trying to find out what something that doesn't fit in based upon expected ranges of data. These are the basic type of machine learning that's there. Then we come to labeled and our unlabeled data. Let's say you want to classify a house by size, given the features, how many bedroom it has or how many bathroom it is having, and correlating that with home age and their size. So these are labeled. So in unsupervised learning, size is missing, but we can look for similarities in our data. So if there are all of the columns, say if there is a bathroom in the house, there's a bedroom, there's a home, and the home age is not that old, we can say it's or if it's a really old home, it could be bigger. Then, as we are seeing from the sample data, that newer homes are mostly short or medium size, while the homes having age of more than 50 are mostly medium or large. So we can derive out or feature engineer these columns in case of unsupervised learning. So machine learning is a methodology to create a model based on sample data and use the model to make predictions or a strategy using a more algorithmic approach. So supervised learning model requires a historical data that contains square feet, number of bathrooms, or zip code, having the target variable in hand, while unsupervised learning doesn't require that. You don't need to have the target variable in your data when you're applying unsupervised learning, while in case of supervised learning there might be a requirement for the target variable. Record that contains the price for which the house was sold for. Iterate the algorithm over the combined data to train the model, and use the trained data to predict the outcome of new records. how much price would the house be given how many bathroom it has, how many bedroom it has. So here, data science is a process of getting from raw data to outcomes, getting from data to wisdom. And there's a whole industry framework on how we do that. So it's all based upon solving a problem or asking some interesting question about how, like trying to find insights in the data. What are the business outcomes of, say, prices of cabs? What's the price for getting a cab from airport to your home, while from your home to the airport? Would there be a difference? That we can only find out when we have the data. So after getting the data, we have to explore the data, trying to find out patterns within the data. After finding out the patterns, we model that data and communicate and visualize the results. Then there are different special traditional data science team that requires a data scientist who prepares and engineer features, and the most valuable skill that is training our models. Then comes the job of data engineer who builds data pipelines, not uncommon to 5:1 ratio. And data analyst who assists the data scientist with the data preparation, and application architect who design a complete solution and deploy and maintain models in production. That's the whole data science framework. Then we come to trends. So it's the trend of automation that has given rise to or birth to data science tool for citizen data scientists, pre-trained models in the cloud. So easy defining success in data science requires easy for tangible and search order optimization, recommendation engine or CTR, lead scoring, attribution, try to measure direct outcomes, and think in terms of return of investment. So that's how industrially any data science projects are executed, from understanding business objectives to deploying models, deploying and updating models. So that's the architecture of different databases that are used to create data marts and business user reporting or doing business intelligence upon the data. So scaling up and enabling more data scientists are the way towards future model management, doing optimizations over algorithm automatically, and improving productivity, support for containerized applications like Docker, etc. Preparing our data, engineer the features or do some feature engineering, train or tune our model, then test the model, deploying and operationalize the model, then update the model, and then again repeat. Makes data science team more productive, broad support for open source libraries in various languages. So we discussed about what is data science all about, common use cases and algorithms that are used in data science career, the whole process of data science, building a data science team, and what's the future for data science. Hope you guys enjoyed the lecture. See you guys in the next lecture. Thank you so much.